Real ice, science and environment. Climate change, the insane plan to save the Arctic sea ice, update 3 days ago. 5 minutes lead by Mark Pointing, BBC News climate reporter. Push on sea ice off Canada's northern coast, Parka class scientists watch saltwater pump out over the frozen ocean. Their goal to slow global warming. As sea ice vanishes, the dark ocean surface can absorb more of the sun's energy, which accelerates warming, so the researchers want to thicken it to stop it melting away. Welcome to the vacuous side of geoengineering, deliberately intervening in the Earth's climate system to try to counteract the damage we have done to it. The related article: Polar bear face starvation as ice melts. More snow and rain is falling in the Arctic. Hottest February marks 9 new monthly records in a row. Geoengineering includes more established efforts to lock up planet-warming gases, such as planting more trees and burying carbon underground. But more experimental measures aim to go a step further, seeking to reduce the energy absorbed by the Earth. Many scientists are strongly opposed, warning that such attempts distract from the critical step of cutting carbon emissions and risk doing more harm than good. But a small number of advocates claim that approaches could give the planet a helping hand while humanity cleans up its act. The ultimate goal of the Arctic experiment is to thicken enough sea ice to slow or even reverse the melting already seen, says Dr. Sean Fitzgerald, whose team at the University of Cambridge Centre for Climate Repair is behind the project. Will it work, or is it, as one scientist put it, quite insane? We don't actually know enough to determine whether this is a good idea or bad idea, admits Dr. Fitzgerald. It's quite cold, the researchers say. Wind chill in Cambridge Bay can make it feel like -45°C. The researchers have been braving bitter conditions in Cambridge Bay, a tiny Canadian village in the Arctic Circle. It's quite cold, Andrea Ceccarini of Real Ice, a British company leading the trip, tell me why a patchy Zoom connection from inside a flapping white tent. It's about -30°C with a strong wind, which brings the temperature to -45°C with wind chill factor. They are drilling a hole in the sea ice that naturally forms in winter and pumping around 100 liters of seawater per minute across the surface. Exposed to the cold winter air, this seawater quickly freezes, helping to thicken the ice on top. The water also compacts the snow, as fresh snow acts as a good insulating layer. Now, ice can also form more easily on the underside in contact with the ocean. The idea is that the thicker the ice at the end of winter, the longer it will survive when we go into the melt season, Mr. Ceccorini explains. A pump is used to flood the sea ice surface with seawater, which will then freeze. Speaking to me to speaking to me toward the end of their trip, they've already seen the ice thicken by a few tens of centimeters across their small study area. The ice will be monitored by locals in the months ahead, but it's still far too early to say whether their approach can actually make a difference to the rapid decline in Arctic sea ice. The vast majority of polar scientists think this is never going to work out, cautioned Martin Seegers, an experienced glaciologist at the University of Exeter, who is not involved in the project. One issue is that the saltier ice may melt more quickly in the summer. And then there's the huge logistical challenge of scaling the project up to a meaningful level. One estimate suggests that you could need about 10 million wind power pumps to thick sea ice across just a tenth of the Arctic. It's quite insane, in my opinion, that this could be done at scale for the entire Arctic Ocean, said Julian Struve, a professor of polar observation and modeling at University College London. Some of the more experimental geoengineering suggestions include trying to make clouds more reflective by generating extra sea spray and mimicking volcanic eruptions to reflect more of the sun's energy back into space. A number of scientists, including the UN's climate and weather bodies, have warned that this approach could pose grave risks, including disrupting global weather patterns. Many researchers want to see them banned altogether. Geoengineering technologies come with enormous uncertainties and create novel risks for ecosystems and people, explained Lily Furr, director of the Fossil Economy Program at the Center for International Environmental Law. The Arctic is essential to sustaining our planetary system. Pumping seawater onto sea ice on a large scale could change ocean chemistry and threaten the fragile web of life. And there is a more fundamental, widespread concern with these types of projects. The real danger is it provides a distraction, and people with vested interests will use it as an excuse to keep burning fossil fuels, Professor Seegers warns. Frankly, it's insane and needs to be stopped. The way to solve this crisis is to decarbonize. It's our best and only way forward. Other article, A Simple Guide to Climate Change. What is net zero and how are the UK and other countries doing? The Arctic researchers are acutely aware of this concern. They stress that they are simply testing the technologies and wouldn't unleash it more widely until the risks are better known. We are not here promoting this as the solution to climate change in the Arctic, Dr. Fitzgerald stressed. We are saying that it could be part of it, but we have got to go and find out a lot more before society can then decide whether it's a sensible thing or not. They agree that geoengineering is no silver bullet to tackling climate change and that steep cuts to fossil fuels and carbon emissions are most important to avoid the worst consequence of warming. But they point out that even with rapid action, the world still faces a difficult future. The Arctic Ocean is likely to be effectively free of sea ice by the end summer, at least one by 2050, and possibly even sooner. As the graph below shows, it's already experienced steep decline since the 1980s. We need other solutions, argues Dr. PhD student Jacob Pentring, a researcher at the Center for Climate Repair who braved the icy winds in Cambridge Bay. We have to reduce emissions, but even if we do them as quickly as possible, the Arctic is still going to melt. Mapped by Erwan Lewald.